Hello friends, now we will see how does the while loop work. We will see here that while loop is taken as I less than n. As we've initialized I to 0, so we will terminate when the value of I is equal to n. That is, the loop will work from 0 to n. Now the first element of the array, that is the original list as seen over here, is 25, 86, 56, 13 and 45. What we've already done in the previous example, the first element of the array is assigned to variable min. As I has a value of 0, so array of I, that is array of 0 at the 0th location, is assigned to the variable min. So my min gets the value of 25. Now we vary the for loop as we have to compare all other elements for this particular array with this value. We say for j is equal to I plus 1, j less than 5, j plus plus. Here I have taken the value as 5, but we've already initialized the scanf value of n. This can be changed to n, but for my example, as we have only 5 elements, this for loop I have put it as 5. But for the more practicality of my program, for my program to have a more practical implementation, the value of j can be considered or should be considered as n. Now, why do we take the value from I plus 1? Because we've initialized the value of min, that is the first value of my element, that is the value of array at a location 0 to min. I don't need to compare the same element with itself, so I have to always start with the next element. That is the reason I start all my j loops for this selection sorts for I plus 1. Now what do we do? We have the minimum value which has the first element value of the array. So min has a value 25. Now we compare the value of min to all the subsequent elements of the array. Wherever the value of min is greater, so that is the point where we need to swap the values. Here we start comparing array of j. J starts from I plus 1, so in our case it starts from 86. We compare 25 with 86, but my 25 is not greater than 86. So we increment the value of j and it goes now to 56. But 25 again is not greater than 56 also. So here again there is no swapping that takes place. That is, there is no exchange of values. Now as we increment the value of j, we reach to a location a of j where the value stored is 13. 25 is greater than 13. So here I need to swap or exchange the two values. Now what do I do? We say min is equal to array of j. That is, whatever value I got at an array location j is now the minimum value. So I assign it to a variable min. After I have assigned to the variable min, now I have to swap the value and exchange the values at a location a of array of I and array of j. So we follow these three simple steps. Swap is equal to array of I. Swap is nothing but a simple variable which is used to store the temporary value stored at a location array of I. In our case, that is the value 25. So swap gets the value of 25. Now the next step is array of I is equal to array of j. Array of j has the value 13. As we say, array of I is equal to array of j, so 13 gets assigned to array of I. So at place of 25 we get a value 13. And the next is array of j is equal to swap. So whatever is a value stored at the temporary variable swap will now be assigned to array of j. So my pass 1 after the sort looks as shown in the figure. So after the pass 1, 13 comes at the first location, that is the beginning of the list, and then 25 goes to the array location j. So after this 3 steps of swapping, we come to a conclusion that the smallest element of the array comes at the beginning of the list. Now we have to close all the loops that we had opened. So now the next step is end of if, end of for. Now after ending the for loop, what do I have to do? This is only for the first pass, that is for one variable. Now as I said, if there are 5 elements, my selection sort will take at least 4 passes to sort this particular list. So I have to increment the value of I, which is given by the statement I plus plus. Here when I increment the value of I, and then I have to close the while loop. This increment of I will continue till the value of I becomes equal to n, which in our case is 5. After continuously working for 5 loops, when my value of I becomes equal to n, that is 5, we come out of this loop and we see how the output is printed. So we give the printf statement and we say the sorted list is the ascending order. For I is equal to 0 to I less than n, I plus plus, and I print the complete sorted array. And the next step is the end of the main statement. Here we have seen a simple small program of how we sort the small 5 elements in an array. The next step that we are going to see is an insertion sort. Now what is an insertion sort? As we all are aware, insertion means inserting something in between a list. If we have 6 elements and we want to put something in between, that is insertion sort. A simple example of an insertion sort is the playing cards in a hand of a person, and you try to insert a card in between. But let's follow a logical reasoning for it. So in the insertion sort, it always maintains 2 zones in the array which has to be sorted. So it is distributed as a sorted and an unsorted array. At the beginning, the sorted zone consists of only one element, that is the first element that we are sorting. As we will see in all these internal sorting algorithms, the first element is always considered as the sorted list from the complete unsorted list of array. On each step of the algorithm, we expand the sorted zone by one element and inserting the first element from the unsorted list to the proper place in the sorted zone and shifting all the larger elements to the slot down, that is the unsorted way. Now in this algorithm, we follow a very simple procedure of pushing the elements from the sorted zone to the unsorted zone, that is my element which is needing to be sorted and which is sorted comes to the beginning and all the unsorted elements are pushed back. So on each step I will get an element sorted and it will be placed at its final location, whether in ascending or in descending order. So what happens next? In insertion sort, if we consider this as our original list of 5 elements, in this 5 elements we have taken 25, 86, 56, 13 and 45. Now what do we do? If you see this, whatever we do at the first instance is known as the first iteration for an insertion sort. For my insertion sort, 25 is at a location I and rest elements will follow as we move further. So as 25 as a location I, so it is compared with all the further elements. Now first step that I do is I compare 25 with 86. So if we see, is 25 greater than 86? The answer is no. So there will not be any insertion sorting method or technique that will be applied over here. So my j gets incremented by 1. My j reaches to a location of 56. Now again 25 is compared with 56. But again we come to the same conclusion that 25 is not greater than 56. So there is no exchange that takes place. So j is incremented by 1 and j reaches to a location 13. It reaches to a location where I find an element 13 and 25 is greater than 13. So here we apply the insertion sort method. Now what happens in this method is, my 13 has to be moved to a location of 25 and rest all my elements have to be shifted. A very simple example of this is, if a person is having a deck of cards in the hand with the same numbers 25, 86, 56, 13 and 45. So we have to remove the card 13 from its location and place it first. So what will happen? My all other cards will be shifted to its respective position, that is one element to their right. Now what will we do? We don't have a deck of cards, we have arrays. So what are we supposed to do? We are supposed to move the element 13 to a location 25 and 56 to the location of 13, 86 to the location of 56 and 25 to the location of 86. This is how it will be done. The actual algorithm implementation we will see in some time. Now after the first iteration, when I am shifting the elements, my array becomes 13, 25, 86, 56 and 45. Now we see that after my first iteration, my first sorted element is fixed at a location first, that is at the value of I. So after my first iteration, this list becomes my input for my second iteration. In the second iteration, you will see the value of I is now at a location 25. So my sorted list has one element and my unsorted list has 4 elements. Now what do? We again start comparing. I compare 25 with 86, but as 25 is less than 86, so again there will be no insertion sort method applied over here. J will be incremented by 1. J will reach to the next location, that is 56. 25 is less than 56. Again there will be no insertion sort method applied and last number is 45. So what happens? This number is already sorted in this particular list. So the final list after the second iteration is this. So 13, 25, 86, 56 and 45. So what has happened, as we told in the first introduction, that as we continue in our algorithm or we continue with our iterations, the sorted list will increase and the unsorted list or the unsorted zone will reduce down. So now what we see, we have out of the 5 elements in the list, we have 2 elements which are sorted and 3 elements are unsorted. So 13 and 25 are the part of sorted list and 86, 56, 45 are the part of unsorted list, and second iteration output becomes an input to the third iteration, which is this. Now for the third iteration we apply what? We again check 86 with 56. Now what do we see? 86 is greater than 56. So we move their values, that is 56 moves to the location of 86 and 86 moves to the location of 56. This is what I get. But as I increment my value of j, what happens? I and j location values are again compared. So 56 is greater than 45. So again the insertion sort method has to be applied over here. And when we apply this, we get the value of 45 is moved to the location of 56. 86 is moved at a location of 45 and 56 is moved to the location of 86. So after the third iteration, it becomes 13, 25, 45, 56 and 86. So now my sorted zone has increased to 3 elements and my unsorted zone is reduced to 2 elements. But we can see and we can presume and we can predict that 56 and 86 in the unsorted zone are already sorted. But still we have to apply the insertion sort method. We see that 56 is less than 86. So again there will not be any insertion sort method applied over here. So my fourth iteration gives me 13, 25, 45, 56 and 86. So after my fourth iteration, the 4 elements are sorted and 1 is remaining. But when we check in the fifth iteration, 86 is the last element and we always need number of elements minus 1 to sort my list. That is, the number of iterations required to sort any list is always number of elements minus 1, so that is 4. And we will see, we have seen this, that the list automatically gets sorted when we reach the last element in the array or in the list. So in the fifth iteration, my array is already sorted and the list looks like 13, 25, 45, 56 and 86. This is how the insertion sort is diagrammatically represented to understand how the elements are sorted and how the elements are moved from their initial position to their final position in the complete list. Thank you. Now we will see how we implement the program or an algorithm for the insertion sort. We've taken the same list which is and we've taken the same list with 5 elements and diagrammatically shown how the shift has to take place. But now we have to see the code or the algorithm or the pseudocode for it, how it has to be written. Now the first step is for I is equal to 0 to I less than n minus 1 I plus plus. Now what does this statement signify? I start with the location 0, that is my I is at a location for the array, index is 0. So 25 is at an index I value of 0. I vary the for loop only till n minus 1 and n, if it has got a value of 5, which is in our case, 5 minus 1 is equal to 4. So it will be executed for the value of I which is less than 4, that is till 3. Now why we take it till 3? That is for the index location 0, 1, 2, 3. If we see the list which is given, 0th index location is element 25, 1 index location is element 86, 2 index location is element 56 and the 3 index location is element 13. Why we have taken till the index location 3 is my element at an index location 3 has to be compared with the index location 4. If I take it n minus 1 equal to, that is I is less than equal to n minus 1, then I will be unnecessarily wasting a time requirement for the execution as I will be comparing the same element by itself. So we take the value of I as less than n minus 1. If n is 5, n minus 1 is 4, so it will be varying only till the value of 3. As it comes to 4, it will come out of this loop. And for j, I always start with I plus 1 because we don't have to compare the same element by itself. That is, if I start j either from 0 or j from the value of I, then I will be comparing the element at the index location I by itself, which we don't want. We don't want to waste our execution time. So we have to always take the next loop, which has to start from I plus 1. So I plus 1 will be in our case, if I is at a location of 0, I plus 1 will be at a location of 1. So we'll compare the elements at the index location 0 with the index location 1. So if a of I is greater than a of j, that is, a of I is 25, a of j is 86. If it is greater, then we perform the insertion sort. But if we see here, we don't have to perform insertion sort because 25 is less than 86. So we increment the value of j reaches to a location of 56. Here again, a of I is compared with a of j, that is 25 is compared with 56. So again, there will not be any insertion method implementing over here. So we move to j is incremented by 1, so we move to the index location 13. At this instance, we see that a of I is greater than a of j, that is 25 is greater than 13. So what do we do next? We say temp is equal to a of j. So whatever is the value at a location of j, that is a of j, which holds the value 13, will be moved to a temporary variable temp. After we have moved the value at a of j to temp, now we can move rest all the values to its right hand side, that is 56 to 13, 86 to 56 and 25 to 86. How do we do it? As we see here, the value of j has to decrement or reach till the value of I. Till that time, the shifting of elements have to take place. So how do we do it? We see it over here. We say while j is not equal to I, we keep performing the statement. At present, my j has a value 3, my I has a value 0. I say a of j is equal to a of j minus 1. A of j at present has nothing, or because it had a value 13 which we move to a temporary variable. I say a of j gets the value at a location where the value a of j minus 1. So a of j minus 1 value moves to a of j. So 56 now moves to the location where 13 was stored, and then I say j minus minus. So the value of j is now decremented and j becomes now 2. It will continue, it will go up in the while loop, which is end of while loop now. J has a value of 2, I has a value of 0, which is still not equal. So it will again come back into the loop, and a of j at a location of 2, I will have a value of a of j minus 1, which is at a location of 1. So 86 moves to 56. J is again decremented by 1, j becomes 1. It goes up, 1 is not equal to 0. So we again come into the loop and we say a of j is equal to a of j minus 1. So 25 moves to the location where 86 was stored. And then we decrement the value of j and j becomes 0. When we come to the while loop, yes, it is satisfied. J is equal to I, so it comes out of the loop. After coming out of the loop, we will observe that 13, what we stored in a temporary location, is now moved to the value, is now moved to a location a of I. So a of I gets a value of 13. Now end of the if loop, end of the for loop for j, and end of the for loop for I. This is how the first iteration is performed and all other iterations for insertion sort will be performed. Now after seeing what is insertion sort, let's see what are the advantages of insertion sort. Now in this advantages, the insertion sort repeatedly scans the items in the list, each time inserting the item in the unordered sequence into its correct position. The second main advantage is the insertion sort is simple. It also exhibits a good performance when it is dealing with a small list. The insertion sort is an in-place sorting algorithm, so the space required for it is minimal. Now, there are few disadvantages of it too. What are the disadvantages? The disadvantage is it does not perform well when compared to other sorting algorithm because there is lot of shifting which takes place of elements. And when the steps are n squared and the list is large, insertion sort always leads to a problem as the time and the space complexity will increase. So insertion sort is useful. We can say not as a disadvantage, but insertion sort is useful only when my list is small. Now, what is the complexity for the insertion sort? Execution time for the selection as well as insertion sort is n into n minus 1 by 2, and the time complexity for the selection and the insertion sort both are n into n minus 1 by 2. Thank you.